Hi everyone, welcome back to the channel. So we started a new project for a new builder client. It is a pitched roof structure with a livable area inside the roof, so a loft. We've pitched our first pair of rafters up there, checking the pitch, which is 45 degrees. Works nicely. The joisting has been done rather by the builder and decked out for us, which is great. So we can now, we've got a good working area that we can quite easily reach the apex of the rafters and yeah, start pitching up. So let me show you the roof on plan. So this is where I'm standing now. So we've got a hipped end coming up. This is a gable end here, which is where that pair of rafters is over there. Then we've got a hip to crown flat roof in that section over there. A dormer at the front, another dormer here with a couple of large V-luxes. So yeah, quite a bit going on. Valley there, valley at the back. Yeah, so first off, we're going to start in this section here, which is pitching up the rafters with a double ridge beam. There's no steels in this structure, surprisingly, because in the UK that's normally the case. Yeah, so start pitching this up, get the hips up at this end, and then we can work off that with the crown section over there. Right, so our first port of call is double checking this long run of plate is quite straight. It's not too bad, it's slightly bowing inwards in the middle. So how we get this arrow straight is we've got a string line from one end to the other with tension on it, and then we get a block of something the same thickness. So we've got 45mm block of timber, one at this end, one at that end. So if we measure from this plate to the back of that string, that will be the thickness of the timber at each of these ends. If we go along and check that measurement all the way along, we want that measurement the same all the way along. That means then it is straight, as I say, along the whole run, which means the rafters, we can cut them all, well, I already have cut them, these commons. They can all be cut the same, which means it'll be parallel off the ridge, and the ridge will be level, providing this is level as well. So I'll show you us now fixing down the plate. Right, so we've got all this up now in a day, which was good going for us. We've got made up these temporary braces and props, etc. Just gives us an extra pair of hands when we're working so that we could get all the long ridges up. So there's a crown flat roof here to be formed, which we'll do today. It's approximately 1950 wide. So we'll start setting that shortly. So yeah, as you can see, most of the commons are in, other than infilling quite a bit. We've got quite a big window here. This is going to be a bathroom. There's another big window where there's a stairwell in this area here. So we've got a couple of doubles to put in. So there will be some quite wide gaps to allow for the window. The front here, we've just got to put the hips in, obviously infill it all with the jacks, etc. We've got a valley coming up here, another double valley coming up over here, and a dormer to build in this section here. So the pitch is 45 degrees or 12-12 if you're in America, and yeah, the ridge height is the same all the way around. So to achieve the size of the flat roof and the length of this ridge, I'll show you how I've done that now. So I know the run is 2612 millimeters. I've come off the corner to that outside face of that double, so here. Okay, and that's the run of that. Done the same from this point over here where the roof planes up and meets, and then I've got a mark down there, if you can see that there. So if I measure from inside to inside of my mark, that'll be the size of the flat roof at this point. And then to achieve the length of the ridge, plumb down from this ridge here, put a mark on the board. But to get the position of the end of this ridge here, what we had to do is we plumbed up from this wall plate here where the rafters are sat at this end and over there. We've then pulled a chalk line roughly in line, well obviously in line with the plate, pinged it, it's underneath the sheet now anyway. So we've plumbed up from that line, which is that mark I've got there. I've then come off that mark, 2612, which is the run of the rafters, to here. So I know that those rafters are sat at the correct run and that ridge is in the right place at the end there. But so to get the length of it, yeah, plumb down, marked it on the sheet. Plumbed up from this plate and got the measurement from that mark to the level, which is in line with the back of the plate, and it was 6970 from memory. So I then minus the run of the rafter off of that, and that gives you the length of the ridge. So once again, I had to transfer the plate over there, leveled up, marked it on the ridge, came across the run, that gave me the position at the end of that ridge, and then to get the length of this one, as I say, plumb down from the ridge, that mark to up from the back of the plate, deduct the run of the rafters, and that's the length of the ridge. So what we'll do now is get the rest of this bit in and start filling in. Right, what I'm going to do is show you how we are achieving these rafters down this run here. So as you can see from that rafter there, obviously it's sat on the wall plate, which they are all the way around, other than this section here. So the plate line is higher than this. So it's not too difficult. The length, it'll be shorter because we're coming up, but if we just use the pattern rafter that we have, we can still work it out quite simply. So what we want to do, so this plate that I've fixed on here, we're trying to get to the top of this level here. So if I come up 220, which is the height of this double with the flitch plate in, plus another 45, that brings us to the top of this plate where the rafters are going to sit. We know they've got to continue from this rafter, or these rafters, down in this section, and they're sticking up 11 mil from the top of that. So I know that the tail end of my rafter's got to have a 11 mil upstand, then pitch up from that point there. The position of this, I am actually going to move it. I'll show you why in a second. So let's go over here. So here's a pattern rafter which matches all the others. So what I've done is I've come up the 220 to that line there, if you can see that. So that's the top of this beam here. Then I've come up another 45 mil here, done a seat cut line, and then if you see this line here, that's 11 mil allow for the 11 mil upstand that these rafters have got all the way along. So then I've measured the back of this plate where I've screwed it is 170 from the back of this beam. So I've come from there, look, 170 was here, which meant there was a tiny bird's mouth, no good. So we could either leave it where it is and put a double plate on top, which would be there, which gives us the correct height above plate of 139, which it is all the way around, or because I've only screwed this, because I knew it could have, might have needed to have been adjusted, we can move that back, and by doing so, it brings us to here, which gives us the correct height above plate, and cut this out, cut that off. So yeah, then we are going to be sat on here, and that'll pitch up. Right, I'm just about to fit my hips here on this hip end of the roof, and I'm going to show you how I'm working out the length. So I have worked it out with using a ready reckoner, like the calculations mathematically, which gives you from centre to centre. So this is a double hip, and I've decided to back them. I do this of recent, just like how accurate it is. So anyway, I do two ways. I work it out mathematically, so that's from centre to centre. What that does, it gives you from back of wall plate where your heel stand or height above plate should be the same, right up to that apex of the ridge. So to cross-reference and double check, what I like to do is, I don't know if you can see that up there, I cut a template of how it will look. So I've got bevel on here, as you see, it meets the apex pretty much flush there and there. So I hook my tape on the centre, come down, I've got another template down here. So this one, look, obviously it's going to be a double, there's going to be another one here with a bevel coming this way. And this is the correct height above plate here, or heel stand. So I've got 139 millimetres from there to there. So I measure from point to this point. That should be the same as how you work it out mathematically, but it isn't, and that's why I do it this way. So this is, so mathematically the length of the hip worked out 4.518, 45-degree pitch for the span that we've got, and over there, here rather, that has worked out that length, which means this corner is dead square, but this one isn't. This one, when I've measured point to point, it's 4.507, so it's 11 mil out of square. That could be, we've got a long runner plate there all the way down, which was important that it's parallel for the block work, so it's more than likely this one here, or it could be a combination of the two. But yeah, so even with the maths you can use, you know, it's always a good idea just to double check, measure it, and you can then know for sure it's going to fit. You don't really want to have to cut it twice. So I'll show you me installing these now. Okay, that's all the hips and valleys in now then. I'll just take you around, show you all of them in. Plain and lovely. So yeah, they're all in. Backed as well, backing bevels on them. Just makes for a nice job. So next job is going to be installing the jack rafters to the corners, so up the hips. Got a large Velux window to form here still, another big one here, that's why I've got a big gap at the moment. The front section here. There we go. So as I say, the next thing we're going to be doing is getting the jacks in. So I'll do a couple of time lapses of me installing those now. Right, so I'm now starting the flat roof dormer out the back of the property. I'll just show you it on the plans. So there it is there. So camera won't really focus, but that's 840 from finished floor to top of window sill. Okay, I know this window size is 1200 wide by 1300 tall, so I'm going to allow a bit left and right and up and down. Obviously you can see the ceiling is lower than the crown flat roof ceiling, and there's no bulkhead above the window. And as you can see, there's a bit of an upstand, which is typical, or typically rather, 150 mil or 6 inches for the lead to lap up, you know, allowing for the build up of the roof, batten and tiles, etc. So I'll show you how I'm going to set it out, or have set it out, started to. So I've got this timber here. This is going to be the stud wall where the window sits, 840 tall. That's off the subfloor. So once the finished floor rather comes up 20 to 25 mil, window board goes on, which is 25 mil. That will then be 840 finished size. So you can see here, look, I've got an upstand. Obviously there'll be a top plate and a bottom plate on this. This is just to show you until it's built. It's going to be plied on the face of this, so I've got 130 or so off there. So once that's plied, that's near enough. I'll be about 150. So up here, I've levelled out from the crown flat roof. I've got a line here. So what I needed to do then is get the height from this to the top of that timber. So I've levelled out, measured down from that line up there, and I had, where is it, 1433. So the height of the window I know is 1300, so I'm allowing 15 mil in the width and the height, so that's 1315. So 1433 minus the 1315 was 118, I believe. So I've got another line here, if you can see that, this point here. So I've come down the difference, which is there. So that is going to be to the top of the window, allowing for tolerance. So then I've come down from there 90 mil, got another line here. That's allowing for a double top plate on the dormer walls for the flat roof joist to sit on. So you can see I've got timber on here now, but anyway, I measured from this point here down to the point I had here. That gave me the length of this plate I've now got on there, which is for the studs of the dormer wall to sit on. I've got that both sides, as you can see. So now I can get a stud fixed at the top. Well, what I normally do actually is I sit a single top plate on there, longer than it needs to be, with a brace, making sure it's level. Then I plumb up, get my measurement for my front stud, cut off the excess here. Then I infill the studs, then a second top plate and a header going across the top for the window. So you always want to sit, I normally allow a 90 mil bearing left and right above a window or a door. You can do, I think, 45, 50 mil on timber frame, but the more bearing the better really. So I'll do a time lapse of me installing that now. Right, that's this dormer completed now. So I'll show you the detail of what we've done to prevent insects and vermin getting in. So this is a ventilated void for the walls. We've got insect mesh stapled to battens. There's going to be a second layer of 18 mil ply. Reason we're leaving it off for now is because the roofer will lap some soakers and or lead up here. The ply will then come down further to then lap his finished lead around that. So this gives the opportunity to keep it very weather tight. Also ventilated. So yeah, we've done the walls up the side there, making sure nothing can get in. Same this side. So the air has to be able to flow in, flow all the way around, up and out, which it can. And at the top here, I've left this on temporarily because we've got some aluminium vent that's going to go underneath these battens once they're painted black, so you can't see the edge. And then the soffit should finish into those flush with the vent, and then you'll have a bit of an underhang on the fascia. There's a stepped fascia detail on this. So we're done on this one now. We're going to go and do the one down below. Right, so I thought I'd just show you this cold deck roof detail before I board it in with the ply. So here's the main crown flat roof. Already got a sheet on, I'm just loading them up now. So for a cold deck flat roof, what that means is it's insulated between the timbers. So it has to be well ventilated to prevent condensation from the warm air inside the building and the cold air outside the house. So how we do that is counter or cross batten the opposite way to the joists. Furring pieces to create the fall. This is all falling this way, the water. And then what I've done, look, if you can see, I've drilled these 20mm holes in each of these bays. So when this rafter void is insulated, there should be between a 25 and 50mm ventilation void at the back of the insulation behind the felt. So the air can travel up from the bottom, which will be a over fascia vent, all the way up through these holes, all the way around the roof, and then come out the other side, because the air's got to flow up, across and down for it to work. So yeah, we've got this dorm applied in now. Just going to board the flat roof and we're done with this section. Okay, we've got the pitched hip-ended dormer formed now at the front here, as you can see. So the client's gone with a vaulted ceiling as opposed to a flat ceiling, which it shows on the plans. Reason being is this is a bathroom area here. Where I am is there's going to be a bath. So you can sit in the bath, look out your window with a bit of privacy, of course. I didn't get any footage of us forming the dormer walls or the header for the window, but I did get a time lapse of us doing the hips, jacks and valley lay boards, so I'll show you that shortly. Yeah, we're now going to start plying the dormer walls on the exterior and the front. So the detail is 12mm ply structural, and then we've got some 25mm vertical battens to allow for airflow up the side of the dormer, a bit of insect mesh at the lower point of the roof where it meets the eaves, and then we've got a second layer of 18mm ply, because these are going to be lead dormers on the exterior. The 18mm will only screw temporarily because the roofer needs to lap up his lead or zinc soakers up the 12mm. So we'll leave the battens quite high, about 150 off the finished roof. But yeah, let me show you the time lapse of us doing the hips, valley jacks and lay boards, and then I'll come back to you when we're doing the ply and batten detail. Okay, that's this pitch dormer sorted now as well with the sheathing. We've got the ventilation details, you can see 25mm batten, insect mesh, decent amount up here so the lead can be lapped up, same up the side with the soakers. So we've left the front, the sides and this last top piece of 18mm off because, as I say, the roofer will really need to felt and batten, lap up the lead. Then that second layer goes on and then the lead goes over that, because that layer can come down past this lap up. We've got this ply shelf here, bit of a different detail to up the top because we had to scale off the plan to the back of this wall to the front of the brickwork as a metre, and then there's a specific height of 750 to this sill, which is why it's ended up further back, because typically you normally frame where you have a clear 150 upstand of the frame of the sill sticking out the roof, but because of the scales and how this detail needs to work with the bath sitting here, that's why I've had to form this ply shelf. So put a 5-degree fall in it, quite a decent fall over that distance, so the water will just hit that and go straight off. It is longer than it needs to be, so that can be trimmed back, and there'll be another downstand bit there, so again lead can dress up onto the tiles. And yeah, so that's this done, and I'll now show you around completed roof. Hope you've enjoyed this video as much as we enjoyed building the roof. Client was over the moon with the end result. As you can probably see, we take a lot of pride in what we do. Everything's neat and tidy, making sure we cover every detail, sticking to spec and getting the job done in time and correctly. So once again, thanks for watching this one, and I'll see you in the next video.